Okay. Hi everyone. Morning and afternoon. So welcome to this week's Rubin Science Assembly. I'm Yumi Choi. I'm your host today. Um, so here's our agenda today. So for the first 5 minutes or so, I'm gonna go through some announcements, and then for around like 45 minutes. We'll do the tutorial run through. I will start with the first TP 0.2 number 6 photo tutorial on um, DS9-like functionalities available in the Firefly-based RSP portal, and then introduce and cover a few of the DP 0.2 portal how-to tutorials. And then in the final 10 minutes, we're going to have some time for questions and discussions. Right. So Rubin Community Workshop is scheduled on at the last week of July in Tucson at Marriott University Park. The meeting will be fully hybrid, but there will be 250 cap for the in-person participation. The registration is not open yet, but please stay tuned. And about the couple upcoming Rubin Science assemblies, next week we're gonna have a regular drop-in office hours. And then 2 weeks from today, there'll be a tutorial session, but which tutorial will be covered is TBD. And on March 13, there will be no Rubin Science Assembly because of a staff event. But from March 20th to May 1st, we're going to have special series of science preparation seminars. And each seminar is going to focus on a specific scientific topics. So you can pick the ones that are closer to your science field and come, or you are welcome to come to all the sessions. I believe the format will be pretty similar, but the details will be optimized for each science topic. Oh, I didn't make the full slideshow. And if you need any support for the softwares and algorithms to work with the LSST datasets, then the Ring Frameworks office hours is the one you probably check it out. So the office hours are on most Thursdays at 10 a.m. Pacific time. So it's going to be right after Rubin Science Assembly over Zoom. Okay, and the Rubin Users Committee is always looking for your feedback about the Rubin data products and science platform, and they are charged with recommending like improvements about those to the Rubin Operation Director in their twice yearly report. So if you have any feedbacks or suggestions about the Rubin data products and science platform, then reach out to the user committee. And finally, if this is your first time to come to Rubin Science Assembly, probably the first action item is to get an RSP account. You can find the instructions here in the link, and then currently the simulated data is available at RSP. So DP 0.2 for extragalactic and galactic objects, and DP 0.3 for solar system object. Right. Any questions? If not, we can jump into the photo tutorial. So if you want to follow along the photo tutorial number 6, maybe where should I put the link? Right, so in the chat, here, everyone. Okay. So if you want to follow along the total tutorial, then go to data.lsst.cloud and log in, and then click the portal aspect. All right, so this is the landing page, but since we're going to explore the DS9-like functionalities available in the portal, we'll do image query first. So to do that, you click the observation type and source for like 3, the calibration level 3, and then leave the data product type and the instrument name as it is, and collection as well, but choose the deep co-ed collapse for the data product subtype. And then as we're going to search image around a portion of a specific region of sky, we can make sure the query type is set to observation boundary constraint points. And then we can type in whatever positions, but we're gonna use RA of 56 and declination minus 34.9. You can pick whatever location inside the DC2 footprint. And then we're not going to do any timing or spectral coverage or object ID search constraints. And then just click the search button. And this is the result page. So you will see images, the coverage and images on the top left, and then the active chart on the top right, and then the result table on the bottom. So you can see we retrieved deep co-eds in this particular location of the sky in all 6 filters. So you will see 6 items in the table. And on the image, you can see there is a just science image layer, and then mask layer, and variance layer. So we're gonna just focus on the science image. So the first thing we want to do, maybe I can make this image a little larger. Okay, so there is a tool icons on the top left of the image panel. So you click it, there are many options. So we're going to explore the layers section first. So you can add northeast arrow on the image. Maybe I should make it zoom in a little bit. All right, so the arrows are on the image, and then you can also add the coordinate grid layer on the image, and then the rulers on the image too. So we can make, and then if you wanna measure a angular separation for the object, we just click the ruler, so you can click and draw between the 2 objects you want to measure the angular separation. So then it will show the angular separations between the two points, the start point and end point, and then what is the position angle of your arrows. So any questions so far? Okay.
Hey, Yumi, it's Gregory.
Oh,
There's another little feature of this that maybe is worth showing here. If you go to the layers dialog, that's the thing with the 5, yeah. You can change the tool to show the offset in different units, including
yeah,
pixels,
right.
and then to also to show the sides of the triangle there. Yeah.
Right. So yeah, I was going to cover that part, but
Oh,
yeah,
great.
thanks.
Okay, excellent.
No.
Okay,
Yeah,
fantastic.
but I think you can change your rulers at any time. So, doing this or doing this. And the offset calculation actually shows the angular separation on each axis. So like 79 separation between the 2 points on the x-axis and 38.9 arcsecond separation on the y-axis. You can change the units here, like pixels and arcsecond, arcminute, and degree. So yeah, thanks. And then about the coordinate systems, you can also, so this is the manipulate overlay display. So you can go there and then you can change the coordinate system for your grid. So currently by default is equatorial sexagesimal units, but you can change this to decimal units. And also there's another coordinate systems you can play with is the read out coordinates. So if you wanna overlay the grid with the equatorial decimal frame, but if you wanna read the numbers in galactic coordinates, you can choose in the read out coordinates here. And then if you are moving around your mouse, then you can see numbers in down here in the galactic coordinates. So if you want to figure out like different coordinates, briefly figure out different coordinates for the same part of the sky, you can turn on the grid in one coordinate system and then pick another coordinate system in the readout options. So you can have two numbers at the same time. Okay. And then the distance tool, yeah, so that was covered already. Is there any questions about the ruler functionality here? If not, we can do another thing, which is uploading a DS9 region file. So in the toolbar, there is a familiar looking icon like DS9 icon. So you can click this one. And then if you have a region file for the part of the sky you just retrieved, that region file could be created from other images or your collaborators share with you. So let's assume there is there's a region file already in your hand, and you can download the region file for the example in the link inside a photo tutorial. Let me see. So I pick my region file from my computer and click the draw. So if you can see, there are the green dots are highlighted. So there are six object was in my region file. So it's marked in the image. So this is how you just plot the sources in your region file when you upload your region file. And then if you want to mark a particular sources on the image from here, you can go to the toolbar and under the layer section, there is an add mark option. So you click it and then the marker appears in the center of the image. And then if you want to mark this particular like galaxy, you can adjust the size of the marker by clicking and dragging any corners of this mark. So now it's labeled as marker number 1, which is kind of boring name. So you want to change that. So click this manipulate overlay display. And now you can see all the list of layers added on this image. So the default image and then image search, which is the yellow crosshair marker here. and then north arrow, and the coordinate grid, and distance tool, and the region file, right? And there is a new layer called marker one, but you can change the label like galaxy. And then you can choose which corner of the marker you want to play that label. So now by default is southeast, but you can do like northeast, and then you can see it's moving around, right? It's changed it to galaxy now, and the label is show up on the north instead of south, right? So, okay. And then you can manipulate these layers here. For example, uh, if you want to temporarily disable any of the layer, you can toggling the button here. Or if you want to delete them completely from the image, then you can click the X button here. I can do like distance, the ruler tool. And also you can change the colors because the arrow and the marker now have the same color. So you can change the marker color to magenta if you want. So all this kind of manipulation can be happen under this manipulate overlay display button. Right. Any questions so far? Okay, if not, another thing we can add is the footprint of other observatories or instruments. So there are like footprints from Spitzer, Sophia, HST, and JWST, and Roman footprint is available at the moment. We can put, for example, Spitzer RF 36, so 3.6 micron footprint is on. And then we can add another one like Roman footprint, maybe on. Okay, the colors are all same. Maybe we can change a letter and or JWST near cam. So things like that. So, and again, go to the manipulate overlay thing and change the colors. Maybe we can try brown, something like that, or this one to be magenta blue, right? Yeah, things like that. So you can play with this. Also, if you want like black background and then the bright colors for the source, I think we can do invert the color map of the image. So now the black for the background and then the white for the source. Okay, so if you are satisfied with your image display and you want to use this for your paper or put it in your presentation, you can do like save this file as a PNG file to keep all the layers you added. So you can say change your file name and then save. If you're saving as a fits image, then the layers you added is not going to be saved. It's going to be just the default fits image. Right. Any questions before moving to the analysis tool section? Oh, yes. So you can move around the footprint and then also rotate it. So there's angles. So for example, you can try like 30 and you can see it's rotated, right? We can do other things, it's rotated, right? Okay, so Maybe gonna remove all the things here and then move on to the analysis tool. So this is, so in DS9, there is analysis functionality as well. So we're gonna explore some functionalities available in the RSP as well. So first one we're gonna try is the extract pixel values along a line. So it's like the 1D brightness profile of a source. So click the tool button again, and under the extract section, there is a line extract, right? And then here you can set the aperture, how you wanna combine the values, how large. So it could be, because it's line, it's 1 by 1 or 1 by 3 or 1 by 5, 1 by 7. Greg, is this the only aperture available at, or is it gonna be more like user
No,
can
it's
just
just
type?
no, it's just a fixed list at the moment. I mean, definitely always open to wish list items, but there's no work planned on this at the moment.
Okay, okay. So to get the 1D brightness profile, you can draw a line on image to extract point online and show chart. So let's say you're drawing a line like this, and it will show the digital number on the y-axis as a function of the x-axis. So start point to the end point, and you can see it's the profile for the image. And then uh, if you wanna chart this table, pin chart or table, then it will add a new table, which is giving you like along the its positions starting from 0 to whatever, like 40-ish pixels. You will have the values along. And then also the 1D profile is chart pinned on the active chart. So also you can download the table, probably like CVS or whatever format you want. And you can also save this 1D profile image as a PNG file. Okay. Any questions about the like 1D brightness profile?
Yeah, again, if I
Uh,
can just add something to this, you'll notice it extracted the values from all three extensions in the FITS files: image, mask, and variance.
mhm,
Not just the image, so not just the flux value,
mm,
but they're all in the table, right? They get
yeah.
extracted simultaneously into the table, regardless of which one is being displayed. And
Mhm,
so you can do things like you can make a scatter plot of the flux versus the variance and things like that, which can be quite informative.
yes, yes.
Um, so
So,
all the
right.
usual tools for working with graphs and tables are available here.
Thank you, thank you. So you can make new plots here, like using these columns, right, in the table,
Yep.
right? So yeah, make a scatter plot. All right, and then
There was a question in the chat, and I don't
right,
quite understand the question, so maybe the about data units.
Yeah, hello, can you hear me?
Yeah.
yeah.
Yeah, this is Palian from Space Telescope. Thanks for the demo, it's really interesting. I noticed that when you mouse over and also on the table, the image column and also the value. Oh, I see the DN now. I didn't see that before. But the image column didn't have a unit attached, so I'm just wondering. And also, is this data really only in DN? I thought maybe this was like calibrated or something.
So that's a question for the pipelines team. And I have to admit that the DP 0.2 data was prepared so long ago. I used to know the answer to that question, but I don't remember why it's not showing that it's in calibrated units. So my guess is that the units in the table are not being populated because there actually isn't a B unit header in the image. That's just a guess. Because we do pick up, if there's a B unit header in the image, we do pick up those units and put that in that table. So my guess is that that's not true. Otherwise, there's maybe a bug we could, or a regression, because it certainly has worked in the past. You can search for B unit if you want. There's a search field at the top of the keywords. Yeah, so the pipelines didn't populate a unit for this, and so we don't put the unit in the table if it's not explicitly published.
Oh, so why is the DN attached to value? Is that a
It's a good
default?
question. I think that's probably a historical default. Um,
Mhm.
I I can look into that.
Thank you.
Or anyone from the CST members know the answer? Probably not. Okay. Then let's move on to the extract pixel information for selected points and save as DS9 region file. So when you're working on the image, you wanna pick some interesting object and then save those the positional informations as a region file for later use or to share with your collaborators. So to do that, we go to the extract section, the toolbar on an extract section, there is a point icons, right? So maybe, and then you can click like points you want. No, something like that. And then just pin the chart again for further analysis, but you can save the table as a region file, right? And then you can change the file name and then just save it. So you can use this region file for DS9 as well and outside the RSP polar aspect. To upload to load in other use cases. All right. And then let me make images a little large. Too large. Okay. So this is the how you select the points on the image and then save them as the region file for later use. Okay. Is there any questions? Okay, if not, we can do, so we select like a couple of objects on the images, and now what you want to do is look at, is there any like multi-epoch observations for that particular source from the LSST. So we can do that by selecting one object. I picked the ones that are pretty bright, maybe a less bright one. And then there is a lamp icon on the top right corner of the table panel, and you can select the search tab at row. So you click it, and then it leads to the general tab page, and so you can see that coordinate is already populated for you in the spatial constraint box. And then you can set the searching radius. So, because I'm interested in any multi-epoch observation of this particular source, I'm going to set this radius to 1 arcsecond. And then we don't do any temporal or object ID search. And then, make sure that we are looking at the DIA source object. All right. So not temporal one. So uncheck the temporal box to make sure we're gonna retrieve all the data for this particular source. And then, all right, search. So this is query all the data, the time variable data for this particular source within like 1 arcsecond radius. And you can see the DIA object ID are all identical, not very identical. Some of them are different. Did I do something wrong?
No, I don't think you didn't do anything wrong. I think I've seen that before as well.
I'm sorry, what is the
Okay.
mystery? I was taking notes on the previous topic so I could follow up on it.
Yeah, I was looking, I was expecting I'm retrieving all the identical DIA object ID sources, but probably inside 1 arcsecond searching radius, there
Oh
are
yeah, no,
other
there's more
sources.
than, yep. I think that's what you discovered. Yep.
Yeah, all right. So then if we wanna like make a like flux versus the time plot for this retrieved data, then you can make a new chart by clicking this plus button. And then we're gonna make the scatter plot, and x-axis, we're gonna add the MJD of the observation. And then on the y-axis, we're gonna put the aperture flux, and we're gonna plot the errors as well. AP plus error. So we're gonna make a new plot. Right, not this one, right. So this is the flux variation of the source, the search in the table over the MJD of the observation. So you can see this, if this is coming from the same object, then it's showing the variation over time.
So Yumi, since you
So,
do have more than one object, I think what you could do is you can go to the header of the D object column and click on the little triangle there,
right.
and then just pick one of them, right? And then that will filter it down to just that light curve.
Cool. This is really great. Yes, right. So if you find multiple object in like 1 arcsecond searching radius, yeah, you can do pick which unique object you want to plot. You can do this way. Okay, so filter. And then if you clear the filters, you can just clear or unclick the whatever select checked box.
You still have
Okay,
to click apply when you do clear.
Right. Oop. Okay, clear and apply. And it will add more data points, every data points in the table. Okay, cool. Thank you, Greg. All right, any questions? Right, if not, now we can move on to the DP 0 how-to photo tutorials. So late January, like 13, photo how-to tutorials were released. The purpose of this how-to tutorials are, is really concise and just functionality focused, and it doesn't have any scientific context or motivation, but just describe how you do things. So this is a list, for example, like how to navigate the user interface, how to execute a user interface query, how to execute an ADA query, and things like that. And more little how-to tutorials will be added over time. But today I want to just go go through 3 of them, which was not covered in my the DS9 functionality tutorial. So I'm gonna go to the number 2, how to execute a UI query. So this one, if you log into the RSP and go to the DP0.2 catalog tab, and then there is a collection of the table collections, and then also which tables are available for each collection. So you can select the tables you want to run the execute and query on. And then there is a enter constraints like spatial, temporal, or object ID. And then there's a table on the left. You can choose some columns you want to have in your result table. So that way you can have a lighter result table, then all the columns are included. So you can click which column you want, and then just put extra constraints on each column if you want. So for example, if you want to only have the primary source and then exclude all the duplicates, then you can set the detect underscore is primary column to be 1. And then if you want sources that are brighter than some magnitude, you can also put that constraints. So in this example, we're asking to retrieve all the objects that are brighter than 25th magnitude, which is 360 nanojansky in all the filters available. Also, if you are only interested in the extended sources, like the galaxies, then you set the ref extendedness to be 1. And then just hit the search button in the bottom, and then it will be the default results table, result view. So active the coverage map on the top left, and then the active chart on the top right, and then result table on the bottom. So this is how you do the UI query. And then you can do the same query, but by executing an ADQL query statement. So if you set up all the same, identical to the previous example, and then there is a little button, maybe I can make a little larger, like populate and edit the ADQL. So if you click that button, it will populate the ADQL query statement for you. And then you can just click search to get the same result. And the other option actually is in the main the DP0.2 catalog tab. Instead of the UI interface is UI assisted button is clicked, but switch to the edit ADQL button, and then it will lead you to the ADQL interface page and with an empty box. So you can actually put your own ADQL query statement here. And as an example, we provide an example statement in the how to put tutorial. So you just copy and paste this query statement into the empty box, and then click the search button. It will give you the same result view. All right. And then the last example how to portal that I want to go through is the number 8, how to use the results active chart. So this one I want to actually show and actually do it. So we do like TP0.2 catalog, and then click the edit ADQL. In the empty box, we copy and paste the query statement, and then click the search button. And you can close all the unneeded query results if you like. So I'm doing it now. Oh, is that right? Right. Okay, so here what we want to explore is the active chart with a little bit of focus. And so you can see there is a one object is highlighted in the active chart, which is by default plotting the first two columns in the result table. In this case, RA and DEC. So this highlighted object is also highlighted in the table. So if you move around,
You mean if you
and
switch the upper left pane to the coverage tab, I think that that also then
right,
shows the data overplotted on an image. You have to
right, right,
zoom
right.
in somewhat there to actually see the individual points.
So, zoom. So there is individual points. Right.
You'll you can zoom in a couple, one or two more clicks there.
Yeah, right. And then you can click here, also highlights on the active chart and the table as well. But in the like active chart, there are a couple different buttons, icons available. And then this is like zoom in, so you can select a region and then it will zoom into that region. And then this hand icon is the pen, so you can move around the area with this. And then this dotted square is for the zoom. No, select. So you can select a sky of region you want to select this way. And then, oh, why the new icons are not popping up here? Should I go back to the default view always?
That's a good question. I'm surprised something weird is happening there.
Yeah,
Yeah.
okay. All right.
Mm.
So, and then if you
Hmm.
want to delete all the things, activities you just did, there is a restore. So it go back to the default. And
Try
then we
selecting
can,
again now that you've done that.
yeah, right. So we can select again.
Yeah, there we go.
And yeah, these two extra buttons are up here. So this one is selecting the object inside your selected region. So it's highlighted in the table and the coverage map as well, right? So
It's
this,
in the table it's reflected by the blue checkboxes, so that
right.
it's a multiple
Mhm.
selection.
Right, right. So this is the uh, the the object in the selected region, and if you wanna to just filter those selected the object in the selected region, there is a filter icon, so you can click in. Then it only shows the object in that area, and now the result table is not showing, checking the object in the selected region, but it's all filtered. So all the items in the current table is only showing the object in the selected region. So I was actually had a question. So can we do like this and then this, but also at the same time, the filter right away, rather than repeating the selection process again?
Do you
This is a
mean if you
question.
have a selection, is the selection region preserved so that you can first highlight them and then filter on them?
Yes.
You can do that, but not the workflow that you, I think, are hoping for. So once you've done this, you can then go to the table, and in
Mhm.
the table, the little funnel icon above the check marks.
Mhm.
No, the other
Oh,
that one,
here.
that does
Mm.
what you want now. If you click that.
Oh, I see. So not from the active chart, but from the
Yeah,
result
that's an
table.
it's an interesting question. Could you, just so I can pass this on to the colleagues, um, what would your motivation be for first clicking the select and then wanting to be able to immediately click the filter in the same spot?
Mm.
I'm just curious. I'm not
Yeah,
suggesting you don't have a reason. I'm just,
yeah.
I'm not sure where you were headed, and so maybe there's another way to do what you wanted to do.
I see. Yeah, I think I didn't have a like science motivation to that workflow, but
But
I see. Yeah.
I will poke at that and see why we dismiss the selection region after one of those buttons has been pushed. It's a good question.
Yeah. Okay.
It's
Good,
a
good.
good workflow question.
Yeah. So,
I'll look into that.
thank you. Yeah, I was just curious if, because at the beginning there was two new icons pop up, and then if you click one, then the other one is disappear. So that's why. All right. And I think this is it for this is it that I want to share today. So this is hopefully give you some ideas what the portal how-to tutorials is for. So if you are just curious, oh, I want to know how to do this without a scientific context, then this is the place you can look it up. So we're gonna make more short functionality focused how-to tutorials. I'm working on one focused on the image queries and etc. Okay. All right, so this is all the tutorials that I prepared for today. Is there any questions in the chat? Oh, yeah, circles. For the selection, you can pick the selection shape. Oh, so thank you. Right. Any like feedback or suggestions and questions? Because especially we have Greg here.
I have one more thing that maybe if you're if you'd be willing to do another search for me, we could demonstrate another capability that
Oh,
pretty
sure.
nice because you did touch on DS source light curves, and I want to show a slightly more advanced functionality that we have.
Okay.
So if you go to the portal and you do a catalog search, if you're
Cool.
I guess you don't have an active window right now. I could do it from here if you like. Shall I demonstrate it?
Yeah, if you want to do that,
Okay,
yes.
sure.
I think.
I have a window that I can use for this.
All right.
Okay, let me get back out of the search that I just did so that we start over from scratch. Okay, so let me share. It'll take just a moment. Okay, Zoom is telling me you can see my screen now.
Yes.
Okay, so I went into catalog search here. And instead of picking dia source, I picked dia object. I mean, remember we were talking about the fact that dia sources are clustered by, spatially to form dia objects. So one way that you can get this data is you can search on the dia source table and then pick apart the resulting objects. But so I have a search set up here in the DP 0.2 region. I just picked the kind of, this is one of our standard reference coordinates for the near the center of the region. Picked 100 arc seconds as my search radius, and we'll execute this search. So dia object is a very wide table because it has columns for all 6 filters, right? And then if a particular source hasn't been observed in a particular filter, then you won't, you'll just see nulls, right, for that filter. And a lot of dia objects are based on just, one or two dia sources, right? If it's some faint transient, you might just have a few. But then there are others like this one where we've got 9 measurements in the G band and, most likely a lot in other bands. So let me first show you the details tab, which wasn't mentioned. So this takes one row of a table and transposes it so that it's vertical. And you've got all the descriptions in one place with the numbers from that column. So as you pick different rows in the main table, it repopulates on the fly. And you can filter this. So I was pointing you to the end data column. If you just wanted to quickly look at just that, we could just type end data in here and then just see the how many points there are per band here. So that's this dia object has things in G, R, and Y, and this one has things in G, I, and R, for instance. So, all right, so that was that part of it. We'll go back to chart here. And you notice on the left, instead of coverage, which, is the usual thing, we've got the data product viewer showing here. And it's telling you you've got an option to retrieve a dia source time series. And that you can also retrieve a force source on dia object time series. There's another option there, but we'll just do dia source for now. And you can choose to narrow it to a particular band, and you can choose like a subset of the columns if you want. Well, I'll pick full. We click submit, and there's the light curve data, and you can see it's in all the bands. Here's this filter name here. So they're all mixed together. We can look at the chart. So this is not a terribly interesting source. I just picked it at random. I didn't plan a demo of an interesting variable in advance here. But this is all the data. If you want to limit it to a particular band, you can filter it here. So we can just pick the R band sources and go back to chart, and we'll see just the R band data. So this is a nice feature in general that you can link from one set of data to another without having to do another search yourself. These tables are, when they're showing in the data product viewer here, you might say, are not a full-fledged participant in your session yet. So if you like this light curve and you want to study it more, you can click the pin icon here, and then it actually will move it into the bottom area here. So you now have the light curve data is down here in the bottom area where there are you have like more capabilities. It's more integrated with other parts of the application when it's pinned to the table area. You can think of the data product viewer as a preview. It's sort of a temporary peek at that data. And then if you pin it, then it's like you're sort of saving it to do more work with. So that's the thing I wanted to demonstrate. So you can go from object to a source-based light curve with this capability, and then you can go from dia object to a dia source light curve or to a forced source on dia object light curve. And there'll be more extra searches of this nature added as we go along, so that you can navigate from one thing to another. Any questions about that?
Gregory, how do you clear the data product table that you've retrieved so that you can go do it for another object?
Oh, we'll just go back to dia object here, and if we switch to another one, it just clears.
I see. Okay, cool.
Yeah. And then you just, you do the search for that object. We've talked about like having that automated so that once you've established that you've done one of these light curve retrievals, that if you change rows in the main table, it'll just assume you want to repeat it. That's kind of on a list of things where we're reviewing what the user experience would be like. I tend to think that would be cool, but we haven't like approved that behavior yet. probably maybe there'd be, you could have a toggle for that. Because sometimes those retrievals can be costly. The light curve ones aren't, but there are other like secondary data retrievals that you can do through this mechanism that take some time. So you wouldn't necessarily want to always have them automated, but it would be nice, right? If you've already picked an interesting set of sources and you just want to flip through their light curves, that would be a nice way to do it.
Yeah. Yeah, cool.
But that's not available yet. So you have to do each one separately. You just have to click for each one that you want. All right.
Cool. Thank you for sharing that functionality. So there are much more functionalities that my presentation was not able to cover, and there are like multiple ways to do the same things. So definitely you want to explore more the portal aspect, and then check out all the portal tutorials, like including the how-tos. So that's our recommendation. And yeah, is there any other questions before we go?
There's one more question in the chat.
Okay.
Um,
What? Can you get force photometry from this tool? I think the answer is yes.
Well,
Right?
so yes and no. I mean, I think probably the answer to I mean, I don't know exactly what the user is looking for, but my guess is that the answer is not yet, but we will. So what you can do in the portal in Firefly right now is, which Yumi didn't have time to display, but I think is in one of the existing tutorials, is you can select a region of an image, um, and then compute statistics on that region. So like you can select a circular region to do aperture photometry on the fly, but that's just like one at a time. And it's just done directly off of the image without, for instance, reference to the PSF or anything like that. So what we have on the agenda, which is not a pure portal functionality, is to have the Rubin science pipelines capability to do forced PSF photometry as a backend service. And then what you would do in the portal is you would pick points on which you want to execute the photometry, and then click a future button that says do force photometry, and then it would send your list of points to a backend service that would actually invoke the Rubin pipelines and do like rigorous PSF photometry at those locations. So that is definitely planned. I don't think that will be available right when DP1 comes out, but I it's something we are planning on working on this year. So I think you'll probably see it later in the year. And the capability that Yumi demonstrated to build up a table by clicking on an image, you just like if you're looking at an image and there are some things in there that you want to save for later, you can just like use that tool that she showed us to build up a table of those. It would be integrated with that. So you would use that tool to build up a table, or you could upload a table from somewhere else if you have a list of AGNs that
Oh, you're breaking, I think. Right. Maybe we lost his connection. But I think the main point is there's much more functionalities coming up and will be available at the end of this year, some of the functionalities. Okay, cool. Yeah, I think that's it for today. Thanks for joining us. And yeah, thank you. Please check out the portal tutorials at your pace. And yeah, see you next time. Thank you, everyone.
Thank
Bye
you.
for now.